All right. Good morning, everybody. Thank you for joining us today for our Decommissioning and Environmental Remediation Innovations at CNL webinar. First off, CNL respectfully acknowledges that the Chalk River Laboratories site is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe Nation. We recognize and appreciate their historical connection to this land, and as a customary keepers and defenders of the Ottawa River watershed and its tributaries. We also recognize and appreciate the contributions that all First Nations, Métis, and Inuit peoples have made and continue to make in shaping this land we now know as Canada. We acknowledge, respect, and seek to better understand the unique Indigenous history, rights, and title on the lands where we work. Before we kick off today's presentation, these webinars feature simultaneous interpretation. If you want to access this webinar in French, click the globe icon on the bottom right and select the language you'd like to hear. Today's session is planned for about 45 minutes, about 20 to 25 for the presentation, and the rest of the time for Q&A. The Q&A icon, you can submit your questions at any point, and we'll take them up at the end. If we don't get to your question, or if we run out of time, or we need to take it for some more information, and if it's a technical question, we always respond later on when we send it with the YouTube link, because we like to post these on YouTube for people who can't make it, and we'll send you the link to YouTube and the answers to the questions. So we do record these sessions to put them on YouTube. And if you are having any trouble signing in or with the video, please let us know at ermstakeholder@cnl.ca, and we will try to get you sorted out. We also look to evaluate these webinars more in depth. So following this webinar, you'll receive an email for a quick 10-question survey. We'd really appreciate it if you take the time to share, so you can give us some ideas on what you'd like to, some topics you'd like to hear about. Today's webinar, you'll be hearing from David Gaunt. He's a decommissioning technologist. Very cool, innovative stuff that they do here at CNL. So excited to hear this presentation. And then after, we'll open the floor for Q&A. So David, over to you.
Morning, everyone. Thanks for the introduction, Mike. So here at Chalk River, we have the Decommissioning and Environmental Remediation group. And in that group, we are the DNER Innovations team. So go to the next slide, please. CNL operates various sites across Canada. We're at the Chalk River site here. And then we also have NPD, Gentilly 1, White Shell, Douglas Point, and Port Hope. I don't know why that one's not on there. Next, please. So what are we? We are a specialized group, and we primarily assist the decommissioning groups with creation of digital twins and visualizations for planning and safety. That includes radiation mapping and all of the robotics that goes along with capturing that data in hazardous environments. Next. So our group started in 2001. My colleague Jeff had received some scans. So part of the process of creating a digital twin is doing a laser scan of the area. And he wasn't really happy with the quality, and also thought that he could do it in-house. So he created the first MVP, which was a cloud-based viewer, which was hosted internally at CNL, and all of the equipment needed to generate the scans. And that has progressed since then. We have done hundreds of buildings, hundreds of scans in various facilities, and we have a whole bunch of cool tools that we use to gather that data, and I'll talk about that today. Next. So here we have a couple screenshots of some of the internal facing portals. We have some analytics. We have the PCAM program that we have, which is the customer facing side where people can put in requests for scans as well as view all of the data that's been captured. For scanning hardware, we primarily use Leica equipment. So we use a lot of their terrestrial laser scanners. RTC 360 is amazing, very, very high resolution images and laser point clouds that come out of that. And then a slightly more portable BLK 360. And we have some handheld equipment, which you can just walk around with, which lets you capture these scans much faster than a terrestrial scanner, but not quite as high resolution. And then we also have some drones. So we have the BLK to fly, Matrice 350 with, I think it has the L2 laser payload on it, and the Helios 3. And I'll talk about the Helios a little bit later. Once we capture all the data, we have to align and denoise the point clouds. So that is a labor-intensive process. You kind of have to take each individual scan, line it up to a previous scan, link them together, and then link all of those into one bundle, which then gives you a visual map of the facility. So here we have an example of one of these projects. So this is a Maple reactor building. And you get like a Google Street Map view. You can click in between the little photo bubbles, but in behind all of these is the point cloud. You can see that here. So it's a 3D representation of all of those points, and you can use it to measure distance, angles. You can use it to do pipe diameter, and you can bring it into BIM modeling software, and then you can create a building model based on the point cloud. And what we typically do is we'll use the visual information that we get from the point cloud and existing drawings that we have on site to create a new building model. Because of the age of the Chalk River site, some of the existing information is not complete. And so we have to update this information so we can give it to our planning teams and engineering teams to assist them in moving forward with the process of decommissioning. So one of the first big projects that we did was the fuel storage and purification system removal. So this facility is in the NRX/NPD fuel rod bays, and it was a water filtration system that took contaminants out of the bay water so that it could maintain its clarity as well as remove some of the radionuclides there. And so we did scans of the exterior of the building. We did scans inside of the highly radioactive room where all the process equipment was. And then the planning team started by mocking up what they wanted to do in SketchUp based on the point cloud and the drawings available. So you can play this now. So here's the exterior of building 204. And this is the scan before and the scan after they've done an excavation. And then the models that the designers put in there. So what they did was they made an airlock and then they cored a hole in the wall of this room that had all the filter systems in it and the piping. So here's some of the scans beforehand. And then they placed remotely operated equipment, so Brock robots, and the decommissioning technologists operated these remotely. So they removed all the pipes, they removed all of the equipment that was in there, they packaged them into waste drums, and then they sprayed fixative everywhere so that it was pretty much clean. You could walk into it just wearing your regular clothing. And here is a scan of the room after. So we have now a digital record of the previous state and the state after all of the removal of equipment. And we did waste volume calculations of how much equipment would need to be removed so that we could plan for using how many storage drums or containers that we'd need to put all that equipment into. So in the same facility, we have the rod bays, and the bays have been drained. There's been grout poured on the bottom and fixative sprayed on the walls, and we needed to get a good laser scan of the base of the floor, kind of underneath one of it's called the weir. So we used the Unitree Go 1. It's a little quadruped robot. It's very inexpensive. And we have the BLK 360 on top of it, as well as a GoPro camera. And then we had a company nearby fabricate us a contamination resistant suit for the robot. So that's probably about $50 per suit, pretty cheap. And it's made of like a material that you'd make a kayak skirt out of. So it's tear resistant as well as waterproof. So yeah, there we go. And in addition to that, we did dose rate scans and inspections of the bay walls. So you can see on the walls, there's this black material, and that's a polyurea liner. So what they plan to, or have already done, is they put grout on the bottom, they fixed the walls with this liner, and then they filled the bays with gravel. Before they did that, we wanted to know exactly what the dose rate profile was on the walls and be able to compare that to what the reduction would be after it was shielded with gravel. So the Helios 3 drone is great. It has a laser scanner on it. It has 4K camera and a little dose rate probe on the front. And so it gives you the drone's position as well as the rate, the video at that point. It's a very good tool. So we did about 18 flights in the storage pool, and the drone accumulated about 170 millirem during that process, which if a person had been doing this scan, probably would have exceeded that pretty quickly. So here's the Go 1. We were doing some testing. I think this is at Gentilly 1. We're doing some scans in behind some equipment. Robot can get back there pretty easily. And then here it is, the dog's point of view getting lowered down into the rod bay there. And so it wandered around for a little bit. It would sit down, we'd take a scan, and we'd go to the next point, take another scan. And then once that was all done, we were able to just lift the robot back out. And so here's the data that the robot collected while it was down in the bays. So again, now we have a record of the configuration of the bays before it was filled with filled with grout. Here's one of the robotic systems that the decom techs used to spray the fixative liner on the bays. It was done using remote tooling again with one of the Brock robots. They calibrated the speed and flow rate so that they would be able to get the correct thickness of plastic on the walls. And here we have drone's point of view, the Helios 3 going into the 204 rod bays. Lighting wasn't super great in there. We were able to do an inspection on this particular Brock robot because it had one issue with it. We were able to diagnose that. And here we are doing a half-meter grid survey of the bay walls. So we do elevations once every half meter of the entire profile of the exterior of the walls. And a visualization that we got, which shows the trajectory of the drone as well as the dose rate of the nearby wall. And once we had all that information, they used gravel slingers and remote packing machinery to fill the bays up and stabilize them so that they can leave them in place while they decommission the rest of the structure. So aside from just the Helios 3 drone, we have some other equipment, and here are some of the visualizations that we're able to capture. So one of the things that we're doing is we are mapping gamma dose rates throughout the facilities that we own, and the equipment is able to localize where radiation is coming from and then overlay that onto the point cloud, which gives the user a much more easy to understand visual of the hazards in an area. And aside from that, you also get the gamma spectrum and local dose rate. We work with universities. So this past 2 years, we've had a co-op student from Queen's University. And this was a project that we had cooked up for her. It was, can you track a contamination probe? So something that can see alpha beta readings from a surface onto the digital twins that we've created. So the first proof of concept was a little limo robot. You can get those pretty cheap. And it had like a basic localization platform on it, and it was controlled on Wi-Fi. And it took them about, I think, 2 months to get a working prototype, at which point we were approached by the Douglas Point decommissioning team, and they had a tank there. And I'll show you what we've done there in the next video here. So it's the turbine clarifier tank. So it was a clean tank, not physically clean, but radiologically clean. As you'll see, there's quite a bit of mud at the bottom of it. So we had the robot scan the bottom of the tank with the contamination probe in order to prove that it was clean so that they can continue with the rest of the decommissioning of the turbine building. So we had them on little tethers. We had another robot with some lighting and a camera so we could get some good shots. And here is a map that the robot created of the various tanks underneath there. So it leaves like little tracks of a square, and it'll give you the count rate in alpha and beta on the map there. So this year we did version 2, the RAV pack. And RAV pack stands for Radiation Analysis Visualization Portable Assessment Kit. And it has a 3D LiDAR, it has a depth camera. It's basically just a very small SLAM kit. And it also has a camera on it that you can point at a detector, and it will do optical character recognition of whatever the reading is. So you don't need to have direct like SDK access to whatever probe you want to use. You can just use the display. And so we've mapped the NRX reactor hall. We've mapped some areas in NRU. So it can do contamination, it can do dose rate, whatever instrument you want to plug into it, it'll record the readings and the position of each reading. And in this next video, I'll show you some of the inspections that we did. So in this one, it's recording dose rate, and the dose rates are represented by cubes, colored cubes, and then it has the reading on each cube. So there's been a couple different environments that we put the robot into. You can see it can go up and down stairs uh, into quite confined spaces. That was in the back of 224, which was, I think it was a liquid waste storage facility. So yeah, we have the ability to map radiation, whether it's a person carrying around lamp, a drone flying around with a dose rate monitor, or a robot dog wandering around getting readings off of that. We also have the humanoid robot. So this is the Unitree G1, and we are getting a remote teleoperation package manufactured for this robot. So you'll be able to put on a VR headset. It will track your hands. You'll be able to walk around, pick up objects, move things around. And it also has a little inductive charger on the back. So if we want to put it in place in a facility or leave it in a hazardous area, we can put the charger down there and then it can just go stand up next to the charger and remain in that area without having to be removed to be charged. And the idea is to do remote teleoperation rather than AI or autonomous operation so that it can be operated by people that have the specialized training needed to do whatever task in the environment remotely. So that's it for indoor robots. Here is our outdoor robot. So this is Remediation Rex. Rex is a quadruped, just like the Go 1 and Go 2 robots. It's a Ghost Vision 60, and the task that we have for this robot is to do outdoor autonomous radiation mapping. So it has a LiDAR on it. It has a GPS system, which is accurate down to, I think, 1 or 2 centimeters. And then on the bottom of it, it has a sodium iodide gamma spectrometer, and it's a 3x3 sensor. So it's quite big, very, very sensitive. It can sense pretty much environmental levels of radiation. So we use this to scan the waste management areas that we have to ensure that there hasn't been any contamination of the environment. So some of the reasons we want to use a robot is to automate the repetitive task. We want to minimize the risk to workers because walking around outside in the bush in the summer uh, in a potentially contaminated environment, you're going to be wearing PPE. It's going to be very hot. Your heat stress is going to be a concern. There's also poisonous plants or insects that might get at you. And another thing is a robot can do the measurements in a very repeatable fashion. So you're going to have very reliable data compared to a person that will be carrying this thing, maybe not walking in a completely straight line or keeping it at a set height from the ground. All of these factor into the activity calculation that the health physics team does to determine if there is anything actually there. So yeah, I spoke to those. Oh, and then also complex terrain. So it's very easy to roll an ankle if you find a gopher hole or a rock or a cut off tree. Um, and also, sorry, you can go ahead with the next one. The surveys take quite a bit of time because the detector has to remain in a certain spot for a certain amount of time. So usually we do a grid survey. So here you can see the command and control software that Ares Security Corporation built for us. Gives you the current counts per second of the robot, as well as the gamma spectrum, and then you can adjust the heat map so you can try and see where something might be. Then you can see the video from the robot. So it will go to a position, sit for a couple seconds, and then move to the next, and then report back on these little colored squares here. And all of this operation is autonomous. One of the reasons we picked this robot was because it is user serviceable. So you can remove the legs. You can tear it down into parts small enough that can be put into an ultrasonic decontamination tank. And all of these parts are also IP68 rated, so they can be submerged underwater for a period of time without any damage. You can clean them in that solution, then take them out and reuse the robot. So that wraps up most of the things that I have, and I'll open the floor to questions.
Okay, thank you, David. Great presentation. We will now move on to Q&A period. So the first question I will get to. How do you see the use of innovations supporting CNL in the next 5 years? So maybe kind of how do you see it evolving over the next 5 years?
So I think one of the biggest things we do is we provide all this information to the planning teams, and it reduces the amount of time and increases the accuracy of the plans so that there's no rework needed. There's no in-field changes. It's all pretty much figured out before we do anything. And that can accelerate the decommissioning process quite a bit. So I think we're going to be continuing to do a lot of scans. We're going to give them all this data, and hopefully all of these projects will benefit from that.
Okay, thank you. Are the scans monitored in real time, or are they recorded and then processed afterwards?
So all of the dose rate contamination or dose rate or contamination numbers we can see in real time. When it comes to like the 3D scans for gamma, we have one system where you can see it in real time, and then another one where you'd have to post-process it in order to see that. So the answer is both. It just depends on what system you're using.
Okay. Will this outdoor quadruped be used for exterior surveys out at Port Hope?
Yes, actually, we've been approached by the Port Hope team. Right now, they have contractors doing remediation around the exterior of buildings. So there's an open excavation, and a person has to go down there and do this type of survey. So if you have the robot, it can just walk down there and do the same thing without having to worry about, uh, I guess, trenching hazards or hazards associated with going into an open excavation.
Okay. How long would the outdoor survey on that large grid take with a robot versus a human surveyor?
So I'll say it takes about the same time because you have to move at the same speed as a human would move. So you can't go faster than a person, and really it doesn't move any slower than a person. It ends up being like a geometric problem where if you have like I don't know, an acre of, well, let's break it down in like square meters. So if you have 200 square meters, you have 200 points that you need to survey, and you need to move between each point, and you need to dwell on each point for like 5 to 10 seconds. So a person will walk at 1 meter per second, I think they do, and the robot will pretty much do the exact same thing.
Okay, thank you. How long does it take to decontaminate equipment?
The physical process itself doesn't take very long. Getting everything lined up to do it can take a little bit of time, but when you have one of the robot legs, for example, it's 4 bolts to remove the leg and then one twist lock connector for the control and the power. And then you just have to make sure that the connector doesn't get wet. You put it in the tank, you can run it for about half an hour, then take it out and put it back on the robot. So I don't know, it could probably be done in like half of a day.
Okay, thank you. Are there plans to use robots for large areas for non-radioactive contaminants? Maybe need physical samples, or are there any other indicators that they can be used for non-radioactive contaminants?
So we have considered putting sampling systems onto the robot dog. Kind of it would be like the dog can go down, sample collector, take something at a specific point, and then puts it into a container and then moves on. Um, we are also investigating ground penetrating radar so that you could either drag that along with the dog or just have it as its own payload so you can see into the ground to see if there's any voids, if there's something buried down there. You can also put gas sensors on there. Like the dogs themselves are platforms to put these pieces of equipment onto. So you can put any type of sensor you'd like on there as long as its payload capacity uh, is sufficient.
Okay, thank you. There are no other questions coming in. Wait a moment or two to see if any come in late. But I will kind of start my outro, as I call it, and see if any come in before we leave. So thank you, David, for the great presentation. Thank you, everybody, for attending the webinar today. Just a reminder, please complete our follow-up survey that we'll be sending. It really lets us know what topics you'd like to hear moving forward. We'll send out the links to the recording of today's session. Feel free to distribute it to anyone who might be interested. And if you have any other questions, you can always email us anytime at ermstakeholder@cnl.ca. I'll do one final check. Oh, there's one more that has come in. There always is. So, in what ways has all this technology and all the stuff you guys do, how has it improved waste management?
So I think the biggest thing that we have done for waste management is we have a way to do volume estimation of how much waste is going to be generated during decommissioning activities. So we use the digital twin and the BIM model. We can tag different parts of the model with different hazard classes and then give them a waste volume estimate based on that. And these estimates have been pretty accurate. Like there's different classes of estimates. I can't remember exactly what number, but I'd say we're within anywhere between 10 and 20% accurate with some of the things that we've benchmarked. And so that once you have that estimate, you know kind of what the cost is going to be to deal with that waste, as well as how much potential storage you will need for that.
Okay, a couple more have come in, so we'll keep going. We got some time. So I'm guessing this is an employee at CNL. How would you go about requesting your team's support as appropriate?
Oh, so we have our SharePoint, and on there is PCAM, and inside of that is the request for scan. So anybody can request a scan. You just need to go there. It says very short form. You just type in kind of what your scope is, where you'd like us to go, what type of information you'd like us to gather, and then that gets automatically sent to all of us, and we'll reach out to you to schedule that work. And we have that for laser scans as well as robotic inspections.
Okay. Can the outdoor unit be used in a fleet for faster survey coverage? Is there geofencing needed to keep it within a property or out of hazards like water bodies?
So with the big robot, you would kind of click on a Google Maps area to define where you want to scan, and then you can put exclusion zones on those areas. So normally what we'll do is we'll do like a perimeter route to record the no-go zones, and then Any other obstacle in there is going to be detected by the LiDAR, so the robot will path around it. So because it's RTK GPS, as long as we have defined the boundaries before we start the mission, the route planning thing is going to keep it out of any of those hazard areas. So yeah, it's pretty much geofenced per mission that we do. And you can have as many robot dogs as you want in the mission planning software, which is developed by Ares. They normally serve for like perimeter inspections, so like security stuff. So you can have like, I don't know, I don't know what the maximum number of robots is, but it's quite a few.
Okay, thank you. All right, we'll do one more. What is the detection limit for the sensors for reliable data?
So the 3x3 sodium iodide detector, we don't have it fully commissioned in the horizontal orientation. So it's been commissioned vertically for a person, but we're still figuring out exactly what the MDA would be for the detector in the horizontal position for the robot.
Okay, perfect. Thank you again. Just quickly, I'll go I'll go over a few things. We post these on YouTube. We'll send you all a link. Um, we'll send out the survey. Please fill it out if you can. And thank you, David, for the great presentation, and thank you everybody for attending. We had a great turnout this morning, and we will hopefully see you at the next webinar that's coming up at 10 o'clock. We'll see you next time. Thank you. Thanks again, everybody. Have a great day.